Hi everyone! So in today's video, we're going to learn about radioactivity, radioactive elements, and half-life. Now, by the end of this video, you need to be able to explain with examples the meaning of radioactive element, radioactivity, and also the half-life of radioactive decay. And we're going to start first discussing about radioactivity. So, what is radioactivity? Radioactivity is a phenomena observed in radioactive elements where unstable nucleus emits radiation in order to become more stable. Now, radioactive elements in this case refer to elements with unstable nucleus which decay spontaneously by emitting radiation. Now, there are many examples of radioactive elements, and among them is carbon-14, thorium-234, radon-222, and uranium-238. Now, as we know, the nucleus in the atom of radioactive element is unstable and decays into a more stable nucleus by emitting radioactive radiation. Now, radioactive radiation in this case could be either alpha radiation, beta radiation, or it could even be gamma ray, which is also known as gamma radiation. Now, this process is known as radioactive decay, where radioactive decay is a totally random and spontaneous process. So, when I say random, what do I actually mean? Random in this case means that we cannot accurately predict when the atom will decay. And what do I mean by spontaneous? So spontaneous means that the decay is not influenced by external factors such as temperature and also pressure. Okay, so the question now is, why in the world does decay happen? Why? The nucleus of an atom consists of protons, positively charged particles, and neutrons, neutrally charged particles. Now, for stable nuclei, there are certain proportions of protons and neutrons that make it stable. So if let's say that the number of neutrons are too many or too few compared to the number of protons, the equilibrium in nucleus gets out of balance, and then the nucleus becomes unstable, which causes it to decay. We have already talked about why radioactive decay happens. Now, let's talk about the types of radioactive decay that exist. So, the first one is alpha decay, the second one is beta decay, and the third one is gamma decay. Now, each type of radioactive decay emits different types of radiation. So, for example, alpha decay emits alpha radiation in the forms of alpha particle. For beta decay, it emits beta radiation in the form of beta particle. While for gamma decay, it emits gamma radiation in the form of gamma ray. Now, let's dive into these types of radioactive decay one by one. Let's start with the first one, which is alpha decay. So, alpha decay is where unstable nucleus of a radioactive element decays into a more stable nucleus and emits alpha particle, okay, alpha particle in the process. Now, let's take, for example, uranium-238, which is a radioactive element with unstable nucleus, and the nucleus of uranium-238 decays into a more stable nucleus, which now gives us thorium-234 and emits helium, which is alpha particle, during the process. Now, moving on to the second types of radioactive decay, which is beta decay. Now, beta decay is where unstable nucleus of a radioactive element decays into a more stable nucleus and emits beta particle in the process. Now, let's take, for example, thorium-234, which is a radioactive element with unstable nucleus. Now, the unstable nucleus of thorium-234 decays into a more stable nucleus, which gives us protactinium-234, and emits electron, which is beta particle, during the decay process. Now, moving on to the last one, which is gamma decay. So, gamma decay is where unstable nucleus of a radioactive element decays into a more stable nucleus and emits gamma ray, in the process. Now, let's take, for example, cobalt-60, which is a radioactive element with unstable nucleus. Now, the unstable nucleus of cobalt-60 decays into more stable nucleus by emitting gamma ray during the decay process. Enough about radioactive decay. Now I'm going to tell you the units for radioactivity, which is Curie and becquerel. Now these two units here are used to measure the rate of nuclei decay, where becquerel is the SI unit. So 1 becquerel is equal to 1 decay per second, and 1 Curie is equals to 3.7 times 10 to the power of 10 decay per second. Now let's suppose that we have a radioactive sample. You need to understand that in a radioactive sample there are many undecayed nuclei, and they're not all going to decay at the same time. So it is impossible for us to tell when a particular nucleus will decay. So we use another method where we find the time taken for the number of undecayed nuclei in a radioactive sample to reduce to half of its original number. And in this case, the time is known as half-life. Let's have a look at this example. Say, initially we have a radioactive sample with 100 number of undecayed nuclei. Now, half of this undecayed nuclei undergoes radioactive decay, and then we are now left with 50 number of undecayed nuclei. Now, the time taken for this process to occur is 15 days, which means that the half-life of our radioactive sample is 15 days. Let's suppose that we once again have a radioactive sample, but this time with 200 number of undecayed nuclei. And the number of undecayed nuclei in the radioactive sample decreases with respect to time. So initially at day 0, we have 200 number of undecayed nuclei. Now, this number of undecayed nuclei, half of them undergoes radioactive decay, which left us with 100 number of undecayed nuclei. Now, this process takes 5 days to occur, which means that 5 days is the first half-life of our radioactive sample. Now, the first half-life just basically means that it is the half-life of our radioactive sample. Now, before we proceed, just for your reference, the red color in the circle refers to undecayed nuclei and the black color refers to decayed nuclei. And let's get back to the decay process. this time, half of this undecayed nuclei undergoes radioactive decay, and we're now left with 50 number of undecayed nuclei. And this process, of course, takes 5 days to occur because the half-life of our radioactive sample is 5 days. But if you calculate the time taken for this decay to happen starting from the initial time, we have 5 days over here and 5 days over here. Add it all up, we have 10 days, where 10 days refers to the second half-life of our radioactive sample. Now, second half-life basically just means that 75% of the initial number of undecayed nuclei have decayed, and we're now left with another 25% of undecayed nuclei. Okay, now this time, this number of undecayed nuclei undergoes radioactive decay, and we're now left with 25 number of undecayed nuclei. Now this process, of course, takes 5 days to happen because the half-life of our radioactive sample is 5 days. Now, if we calculate the time taken for this decay to happen starting from the initial time it started, we have 5 days over here and 5 days over here and another 5 days over here. So we have in total 15 days, where 15 days is the third half-life of our radioactive sample. Now, the third half-life of radioactive sample means that 87.5% of the initial number of undecayed nuclei has now decayed. Now, for your information, this decay process is not going to stop over here, but it is going to occur continuously until eventually the radioactive sample become a harmless material. Alright, so up to this point, we have already discussed about radioactivity, and we have also talked about radioactive decay and the types of radioactive decay that exist, which is alpha decay, beta decay, and also gamma decay. And on top of that, I have also given you the units for radioactivity, which is Curie and Becquerel, and Becquerel is the SI unit for radioactivity. Well, we have also talked about radioactive element, the meaning of radioactive element, and I've also given you the few examples of radioactive elements such as radium-222, carbon-14, and also cobalt-60. Lastly, we have also talked or discussed about half-life of radioactive sample, where I have explained it to you using 2 different examples of radioactive sample. And before we end this video, here are some questions for you to try. Well, I would suggest that you try and answer these questions by yourself without referring to any notes, just to check how much you understand about the concepts that you have learned. And if you want to try answering these questions, you can just pause this video and play it again once you have finished answering. Now, let's discuss the answer for the first question. So the question asks, what is the meaning of radioactive element? And give 3 examples. Now, radioactive element is element with unstable nucleus that decays spontaneously by emitting radiation. And the examples of radioactive elements are carbon-14, thorium-234, and uranium-238. We also have radium-222. If you answered that, it's fine. It's also correct. Now, the second question asks, what is the meaning of radioactivity? And the answer is, radioactivity is a phenomenon observed in radioactive elements where unstable nucleus emits radioactive radiation to become more stable. Now, the third question asks, what is meant by half-life? So, half-life is basically the time taken for half of the undecayed nuclei in a radioactive sample to decay. And this is basically the last questions that I want you to try. So if you find it hard to answer any of the questions that I've given, maybe you can try and watch this video again, or you can even refer to any other resources that is available for you, just to improve your understanding a little bit more. Well, I guess this is all for my video. and I hope you all benefit from this. Thank you so much for watching. Bye!